Hello friends, welcome to my channel. Let's talk embedded. In this video, we will be getting some introduction of a C programming language and why we should learn the C programming language. So I'll be creating a series of the video tutorials to learn the C programming language in simplified and the effective way. The series will be helpful for not only beginners but as well as for the expert programmers. The expert programmers can brush up their concepts using these videos. At the end of these videos, hopefully we will get the answer why you should learn the programming language. The world has been significant advancement in the various fields of technologies and including the artificial intelligence, machine learning, blockchain, Internet of Things, cloud computing, autonomous vehicles, drones, data analytics, data science, Industry 4.0, and so on. So each of these technologies have revolutionized the way we interact with the world around us. There are also programming languages and the tools that use today to build such a massive technologies. Some of the examples of the programming languages are C++, C hash, .NET, Python, Java, MATLAB, Ruby, PHP, HTML, and so on. So the question then would arise why we should learn the C language if there are many effective programming languages available in today's world. Let's get started. Introduction to C programming language is a general purpose programming language and it's not restricted to any field of applications. So we can pretty much use the C programming for any of the applications right from the advanced embedded systems, the low end embedded systems, then the aerospace, the biomedical, the industrial automation, the machine learning, and the web design and development. It's the intermediate level language as compared to the number of language we have to available today, but it's still very close to the microcontroller. So we can pretty much access the low level details or the hardware peripherals effectively using the C language. C language is developed and implemented in the 1978, so it is pretty much old language. So it's developed by Dennis Ritchie. So if you can see at the right hand side picture, the Dennis Ritchie and Ken Thompson, those were working on the Unix operating systems. So the Unix operating system and its applications are developed in the C language. This is how the C language has started. It is the most popular language in today's embedded system development and programming, as it's not tied to particular hardware system. It is used in most of the real-time operating systems, device drivers, protocol stacks, and also numerous applications that we have today. And we also have various libraries available in the internet or the Git space where we can access the n number of libraries or applications which are readily available to start with any of the project or the applications. Before starting to understand the C, first we'll see what is a machine level language. So the machine language is the lowest programming language used by computers or the microcontrollers. It consists of the binary code which is made up of zeros and ones. It is the only language that computers understand, and it's a language in which all programs and applications are eventually translated into before they can be executed by computers central processing unit or the microprocessor. So here at the right hand side you can see these are the probably the machine level code, the example of machine level program, and it is then downloaded to the microcontroller. So microcontrollers only understand the program or the code in terms of zeros and one. So this is one of the examples where we can add two numbers using this machine level code. So in the first line you can see that it's loading the immediate value of 5 into one of the controller's register, Then in the next line, it's loading the new value 3 to another register. Then in the third line, it is adding these two values from the register 16 and 17, and probably it's storing the results back into the register 16. So this is the how we can interpret this the machine level language, but it is very difficult to write or understand. So we need to have an in-depth knowledge of the program, the microcontrollers, then the architecture, and even the details of how the instructions are written in the binary. And it is not practical in today's scenario where we are developing applications for the larger systems. To make it easier to program on the computers, we develop the higher level programming languages, and those languages are compiled and then interpreted, and those are converted into the machine language at the last level. So there are some special softwares that we used to get the high level language processed and converted to the machine level languages. So they could use various stages in between, uh, and those we could call as a compilers, linkers, or interpreters. So C is used for the all microcontrollers and processor. It's commonly used on computer architectures that range from largest supercomputers to even the smallest microcontroller based hardware or embedded systems. The C programming can be used efficiently for the gamut of microcontrollers, ranges from very low-end 8-bit microcontrollers that are available today with the smaller memories to up to 32-bit microcontrollers, or even advanced microcontrollers and that with larger memories. So you can see in the pictures at the left hand side we have the 8-bit microcontrollers from the P16 family from Microchip, and you can see how much memory we have on this controller, the 7 kilobytes of programming memory or flash, and just a 512 bytes of RAM. So you can see how small or tiny this microcontroller is, but we can use the C programming language for this microcontroller, and we can optimize the C programming to get fit into this particular memory size or even the runtime RAM requirements. You can see at the right hand side it can be used for 32-bit microcontrollers like the ARM architecture or other 32-bit microcontroller families, which will be having a huge amount of flash up to several gigabytes, or it is having a large number of RAM, several MBs to few gigabytes. uh, the generated code, it does not always require the system features. So the code can also be run or invoked from some boot code, so even with the boot blocks with smaller footprints. So most of the C codes are written, most of the boot blocks are written in the C code, which is basically start the system when we power on. So we understand the machine level code, then we'll go to the little higher programming level, which is the assembly programming. And you can see here there is one of the examples of 8-bit AVR microcontroller assembly language. The 8-bit AVR microcontroller is used in the today's popular Arduino Uno boards. So you can see the same problem, that addition of two numbers. So how the assembly language could be written to accomplish this goal. So you can see there are various instructions like LDI, that is load intermediate, then add. These are the operational codes or opcodes that are available, and these are some registers that we use for from the controllers to do our operation. So you can see pretty much we are kind of understand so what of course instructions we are using, and we can basically come to know that what instructions or what process we are or what operations we are doing here. So this program will again go through the different passes, and finally we will get the machine level code. So on the other side, if you talk about one of the 32-bit ARM controller, the assembly language, to add the two numbers, we will get the similar program, but here you can see the opcode is different. So move and add, even the register sets they're using are different. So you can see here, even we can understand this program a little better way than machine code, but still it is dependent on the microcontroller family that we are using. So one assembly program cannot be used for the other microcontroller architecture, and we have to write this program for the different controllers in a different way. So there is no portability and no reusable of the program, and one has to learn this instruction set for a given program controller family, and one has to again test and compile these programs while going or porting to the different microcontrollers. So here the higher level programming language come into the picture. So the C here we have a C language code, which is a high level language as compared to the assembly, and it is independent of the target microcontroller. So you can see the function addition, which takes two integer numbers, num1 and num2, and it adds those numbers and return the final sum variables as a function return. It goes again through different processes, and we will get the final machine code similar to what we get from the assembly. But here we can note that the function we have written, it can be easily reused uh, to the different microcontroller architecture without bothering about what instruction set they're using or even what microcontroller architecture looks like. So this is one of the benefit or use case for using the high level programming language. You get rid of the details of the low level hardware or the microcontroller, and we should have a good reusability as well as the portability across microcontrollers. C, it's the most popular language in some of the real-time operating systems that are available today, and most of the embedded systems applications. uh, the real-time operating systems, they need a real-time and guaranteed response from operating system to execute certain tasks or monitor certain events or parameters and take real-time actions. If the action is not taken within a said amount of time, then the real-time operating system is of no use. So there is a time constraints, and things has to be happen in a certain amount of time. The fact C is intermediate language as compared to all other languages. The programs in C language execute faster as compared to the other high-level programming language. Due to the low overheads and direct access to microcontroller peripherals, the board resources, the internal registers, it is a most suitable choice for embedded applications, and we can guarantee the timely execution, and we can get the real-time response when using the C language. There are many critical applications. As you see on the right hand side, there are few real-time operating systems that are written, few examples of real-time operating systems that are written using the C languages. So you can see there are wide number of applications where these are used, like embedded systems, aerospace and defense, consumer electronics, medical devices, IoT, automotive, the industrial, the smartphones, the laptops, and so on. So this is a chart I have taken from the Wikipedia. I see this is a fun chart to see. So this is a chart which shows the popularity of various programming language, but the data is available since 2000. So you can see even before 2000, the C was the most popular languages, and early 80s and 90s, the assembly languages were more popular, but gradually as C was the most efficient and portable and user friendly. The C became one of the popular language in early 90s and even 2000. This particular data, it is not it does not represent number of users, but it just represents how many times the particular language has been searched on various search engines throughout this period. So we can see this the C language is all the time is the second most popular language after the Java. And you can see still till today the C is one of the most popular language, and its popularity is not diminishing. So you can see the Python, which is today, which is used for the various applications like machine learning, data science. This popularity of Python is gaining, but at similar time the C is also one of the important language. In fact, it is gaining its popularity in embedded and IoT, as those are coming into the picture now. So why to learn C? So we have many high-level languages like Python, the Linux, then the SQL databases, some of the advanced libraries. But why the Java, HTML, PHP, and so on? So why we should learn the C? So many of these later languages have designed many of their control structures and other basic features from the sea, so they are inspired by the sea. There's some examples, as I already mentioned. These are some of the examples of the programming language which are inspired by the sea and using some of the features from the sea. So most of them also highly expresses highly similar syntax to C. So if you learn the C syntax, the C logic building, the control flow, the basic structures and variables, probably it will be helpful for you to learn and advance the next level languages and get expertise in a short amount of time, as you have the good understanding of not only the programming language, but also you get understanding of the low level how C interact with the low level drivers or the microcontrollers in that case. So some of the languages are themselves written in C, like the Python language, the Python interpreter, the Java, the Java language, or probably the Linux operating system. Those are written in C. C is widely available, and it is the efficient in terms of the execution and the time critical applications. Uh, the compilers and the libraries and interpreters for other programming languages are implemented in C. For example, the implementations of Python, Perl, Ruby, PHP, those are written in C language. So in this last slide, I wanted to show you the high level picture of what are the different topics or what are the different areas that we are going to touch in this video tutorial. So if you see the yellow bubbles, so we are basically focusing on some of the basics of C, like the data types, the structure unions, functions, then the variables, strings, arrays, and so on. In the advanced stage, we will touch base on some pointers, the pointer arithmetic, function pointers, arrays, and pointers to arrays and structures. The C offers some of the very impactful features which are useful for the embedded programming, and we call it as embedded C. So those features are like bitwise operators, fixed point arithmetic, optimization of the program for the time as well as the memory, the scalability and the portability of your program from one microcontroller to other microcontroller, then some map files that we can explore, and the memory, effective memory management and effective handling of the memories. So we will also understand the C project, how we can handle or the manage the files for the larger projects. Then we will also see some of the processes and the programming flow that are involved from writing a C programming language into the editor to the point where we get the machine level code. So what are the different stages and tools involved? So you can get touch base on these topics. So thanks for watching this video, and please do comments if you would like to share your experience with the C programming language. I would love to interact with you, and please hit a like button if you like this video, and do not forget to subscribe to my channel to get updates on the future videos. Thank you.